Alright, hi guys. Today what we're going to talk about is the history of the atom, specifically kind of how they came to figure out what an atom was made up of. Okay, so first, if we really look and think back to what John Dalton and what he was thinking of, okay, when he talked about atoms, he was saying that these are the smallest indivisible parts of any type of matter and that each atom is different. So if we're looking at these, okay, we can see that, right, we got a red atom right here. That might be one element. Then we have a second element, and this is a different type of atom. That's the blue one here. Then we got this yellow atom, and we got a green atom. Basically, but they are the smallest part of anything, and nothing, I mean, they're their own entity, right? It's like saying it's a marble, but on a really, really, really small scale. Okay, now, when we kind of think about that, though, there's a couple things that we're going to have to change our thoughts of, and they were some experiments done by a couple guys, and that really changed our thoughts and ideas about what happened and what's going on within these atoms. Okay, now the first one is this experiment that we call the cathode ray experiment. So it's a very crudely drawn picture of a cathode ray, but what we have here is we have the cathode part, okay, or just it's a tube that has a vacuum. That means that there's no air inside of it, and you're going to see that there are two cathodes, okay? So there is a cathode, which is a metal disc here, and you have an anode, which is a second metal disc. Now, these are actually going to have charges on them, and if we look at those charges, the cathode is going to have a negative charge, and the anode is going to have a positive charge. Now, what we found is that when we hooked them up to a battery, okay, we started to see what is essentially a beam of light that went from the cathode to the anode and straight across. Okay, now, the reason that this was kind of cool and what this meant for us is that if we put something in between this, okay, so if we put an object, let's say right here, right, stick person. Okay, if we put an object here, what we found is that it left a shadow on this far side. Okay, so we could see that it left, a shadow over here, which was really, really kind of cool. All right, so let's get rid of those things. There we go. Okay, they're gone. So the next thing that we found out is that if we put a paddle wheel here, and think of a paddle wheel like on the things on the back of a ferry. Okay, it is a circle, right, with a bunch of prongs on it. And if there was a track there that it was sitting on, okay, that when this beam was going through, it would actually move this paddle wheel, and it would go from one spot, okay, and it would kind of move along, and in this direction here. Well, what was really kind of cool about this is something had to actually push that paddle wheel along, and they found out that it was, in fact, this. Let's go back. There we go. All right. Oh, that's gone now. Okay, so we're back to kind of where we're at. The third thing that they found, and the reason this was really, really cool, is this supported this idea that there is actual particles that are going across here. Well, they knew that it wasn't an entire atom, though, and that it was just the electrons, and how they knew that specifically, or that there was a negative part to this, is because when they held a magnet up to it. All right, so if they held a magnet here, right, the amount of those ends is going to be there. Okay, what they found is that instead of instead of going straight across, it actually pushed it. Let's use a slightly different color. It would go down. Okay, so we can see that now it's getting pushed downward, right, kind of along this slope, and away from that magnet. Now, the same way, we can see that if we put a different, or a positively charged substance, right, so if this one was negative, okay, it'd go away from it. Or if we put a positively charged magnet down here, you know, okay, we'll say it's the red side, you know, they get pulled towards that. So this kind of made the idea that there wasn't just this single atom, okay? There wasn't just a single ball that made up that atom, but that we started to have this negative, get that out of the way, kind of this here, where we have kind of more of this like positively charged outside, okay? So that this outside part, the blue part here, all of that is positively charged, and then the negatively charged things are these little kind of like chocolate chips inside of a cookie. Okay, back in the day they called it the plum pudding model. Plum pudding was kind of hip up in the day, but more accurately for us today, you know, kind of like a chocolate chip cookie. So let's get that back away. So now we're kind of this idea that there is a positive and a negative area in this space. Okay, now the next real discovery is where we get to kind of this picture of the atom that we're more familiar with today. And that's because now we have this formation of the nucleus. Okay, this middle part right here. This was an experiment done by a guy by the name of Ernest Rutherford, and this might be one of the most influential experiments ever done in science. Okay, so let's explain what's going on here. First, we have this screen. Okay, this little blue line around here indicates a screen. And all that it does is it detects when a particle hits the screen. So if a particle screen hit right here, a little red dot would show up, just kind of like my pointer is now. Or back here, 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 wherever in this case, a proton hit, or just an alpha particle is what they came to be known. Whenever that hit the screen somewhere, it'd light up and kind of make a little black dot, and they could show and mark where it was going. Now, in the middle here, this was a piece of gold foil. So kind of think of aluminum foil, except it was made up of gold. And then here in this little gray box that we have, that's where they put a radioactive substance. And what they knew about radioactive substances is they shoot particles off. So, and that's by this little yellow line that you can barely see, okay? So right along where my red pointer is. So what he did was he shot these pieces of, you know, atoms through the gold foil, and what he found is most of them went straight through. Okay, so they'd go right here, they'd go straight through the screen and just kind of hit the back of the screen right here. So they had basically a whole bunch of, you know, things that hit the screen right where my dot is going off. All right, so you can kind of see that. But what sometimes happened is it would go here and bounce back and hit the screen over here. Well, that's kind of confusing, right? That if it's going here and they're going to just keep hitting the screen on these other sides, well, that means that most of the time it goes right through, but sometimes it's going to bounce back. And that's really, really, really confusing, because how can you go through something most of the time and only bounce a couple times? Because this foil is solid. There wasn't ever a hole in the foil. Well, essentially what was happening is this gold foil is kind of like a chain link fence is for us today. And if you took a bag of marbles and started throwing them through the fence, where would most of them go? Well, they'd go straight through. But occasionally one of them would hit the fence and then bounce back. Okay, it'd bounce back towards you. Well, what that did is it told us, you know, two things. One, most of it is empty space. Okay? And two, that there is something really, really dense in the middle that it's bouncing off of, coming back at us and causing it to move. Okay, so this is what we call the gold foil experiment, and it led us to this picture of the atom again, okay? So if we go back and look at this, right, basically we had 10 of these atoms lined up side by side. Okay, so there'd be one here, one here, one here, another one over here. And what was happening is most of the atoms were getting shot straight through. Okay, notice the little red dot is just moving around the nucleus. But if they came and hit the nucleus, well, they'd bounce back and go that direction. Or it'd come here and bounce back again. So it was this idea that, well, it's mostly empty space. but there is that something dense right in the very middle, okay, right here, and that's how we came up with this idea of the nucleus. All right, those are the two really big experiments that we were talking about, and we really kind of have to appreciate, because those are two huge experiments as to what was going on with and how we came up to this idea that there are protons, neutrons, and electrons in the atom. Okay, next time we'll start talking about the actual protons, neutrons, electrons, and really what makes an atom, but again, we'll save that for another day.